This lesson aims at introducing and explaining the main structure of two outputs of the Set for Food project: the decision support system to select appropriate energy technologies for food utilization, and the guidelines which explain how to implement them. They are open access resources available on the Set for Food website, along with other material of interest. Let's start with an introduction to the concept of DSS, acronym which stands for Decision Support System. There is not a comprehensive definition of DSS, but the term is generally referred to an interactive system intended to help decision makers to use information from raw data, documents, personal knowledge, and/or business models in order to identify and solve problems and make decisions. One of its main important characteristics is the middle-out design approach, which means an adaptive process of design and usage where the user contributes to improve and build the DSS. Define fixed models of DSS is misleading, but the scientific literature proposes different taxonomies which help to classify a DSS through different levels, such as the user level. It classifies the DSS on the basis of the interaction between the user and the system, from a passive DSS which cannot bring out explicit decisions, suggestions, or solution, to an active and a cooperative DSS, which can bring out such decision suggestions or solution, and even allow the decision maker to modify, complete, or refine the decision suggestions provided by the system. In Set for Food project, the DSS aims at supporting humanitarian actors to select appropriate energy technologies for food utilization in temporary, quasi-permanent, permanent camps, or informal settlements. It is an active DSS and focuses on all the 5 main macro areas related to food utilization: technologies for cooking, food preservation, power generation, water treatment, and water pumping. The decision process led by the DSS starts with the first interaction between the system and the user, who collects specific information from the local context and provide the inputs to the DSS. The system computes an output in the form of a sorted ranking of appropriate technologies for food utilization. This information will support the user, which, thanks to both his own experience and the results from the DSS, will get the final decision regarding the most appropriate solution. Now, let's come to the guidelines. As for the DSS, the aim is to guide the selection of different solutions that permit to reach the most appropriate technological options, starting from the local conditions, needs, and constraints. The guidelines provide the users with a list of possible energy solutions for food utilization, which respond to specific local needs and resources. All the technologies have been grouped within the same 5 macro areas related to food utilization previously mentioned, and which have been analyzed through a 3-level scheme. The first level is an overview of the problem and of technological solutions, where cooking, food preservation, power generation, water treatment, and water pumping areas are analyzed starting from the specific context of humanitarian interventions. Then, the technical sheets gives information about the main characteristics of each technology, as well as indication about the possibility of local construction, warnings and specific requirements, operation and maintenance, and an indication of costs. Lastly, the comparative tables compare all the technologies analyzed by highlighting the pros and cons of each one, in order to support the identification of the most appropriate technology for each area of intervention. The last section of the guidelines is devoted to innovative aspects and solutions. The most innovative solutions implemented through the pilot projects are here described, highlighting the methodological process followed for reaching those results. In the diagram, you may see that it starts from the analysis of the priorities in terms of needs identification. Then the diagnosis follows, which focuses on the assessment of the local resources, the analysis of the stakeholders, and the possible future scenarios. It continues with the selection of the strategies toward the DSS, and finally with the choice of the most appropriate technologies and the introduction of technology improvements. In this framework, the importance of a multidisciplinary approach and cooperation between different actors and stakeholders with different skills and scientific backgrounds is highlighted. In the framework of the Set for Food project, these have indeed been the essential factors which have led to innovative solutions.